In Germany, we saw the first AIDS cases among drug addicts in '83. They were late '82, early '83. And you may know that in '84 we started on major campaigns in Germany, trying to educate the people and tell them what HIV is and what HIV is not, and what AIDS is and what AIDS is not.
Were heterosexuals the last to see this disease, just like in the United States?
Say again?
Were heterosexuals the last to see the disease, just like in the United States?
Yeah. First the gay community and the IV drug users, then the hemophiliacs. We quickly realized that this population was heavily affected, and then the heterosexual people. The life expectancy after diagnosis was very, very poor, very short. The first IV drug users died in '84, '85. They must have contracted the virus maybe in '80, '81 probably, a little later. So the first full-blown AIDS cases, as I said, were really described late in '83, early '84. And some of them died quickly. We had a lot of contact with them. We needed their blood. We wanted to learn something about the infection. And then I think, in contrast to many other countries, in Western Europe and in the United States, in North America, Germany responded differently, namely with a full-blown campaign to prevent transmission, HIV transmission, telling the people what we know about the disease, telling the people what we don't know about the disease. Most importantly, telling people how HIV is transmitted and how it is not. The people knew nothing. We as scientists and also as medical doctors knew very little about HIV and AIDS, but the public at large knew nothing. So we had to start an all-out campaign to reach out to the people and prevent transmissions. And I think we were extremely successful, as we realized only years later, because Germany has a very, very low incidence. And this was probably due to the fact that we talked about HIV and AIDS in public in a very free language before other countries followed suit. No religious restrictions, so to speak, or other taboos. We had a health minister at that time, or Secretary of Health, who was very active, supported us, went out into the media, talked about condoms, condom use, talked about safe sex and what that means. We told the public that HIV is not transmitted by kissing, it's not transmitted on the toilet, it's not transmitted using the same door or so with an HIV-infected person. We said very clearly that HIV is only sexually transmitted or through blood and blood products, but this problem was solved within about a year. By the end of 1985, the blood transfusion system was clean. In Germany, we didn't really put any theories forward as far as the etiology is concerned or what's causing AIDS. Some people talked about the poppers, that would make an immunodeficiency. We never believed it because we had poppers before and other drugs. The other theories about viruses that originated from Cuba or from the KGB and all that stupid stuff was not taken seriously in our circles here in Germany. Unfortunately, as you know, there's a German scientist in the United States who played a very unfortunate role as far as the origin of AIDS is concerned, indicating that HIV is not the cause of AIDS, and that caused and still causes a lot of problems and is costing lives.
How did you get involved in AIDS?
Well, what was very simple at that time, I was working mostly with avian and mouse retroviruses, so the technology was available. We had the tissue culture, all sorts of virological and immunological assays. I was working already at that time in one of the federal institutes, a Paul Ehrlich Institute in Frankfurt, and we were also responsible for issues of public health. So when AIDS came up, when Gallo came up with convincing evidence and Montagnier with suggestive evidence that a retrovirus is involved, we said, okay, if it's an infectious disease, then why not a retrovirus? And if it's a retrovirus, we have to work on it because we know the technology to work with it. And there's, as you know, also a certain risk factor. You've got to know how to handle such a virus to avoid infections in the laboratory. So we were obliged really to get going, and we also wanted to clean up our blood transfusion system. So within weeks we had all the test assays established to give it out to the blood banks to test German blood donors. Then we realized that there was already more HIV in the countries than we had anticipated, because as we all know, the people remain healthy normally after infection for several years. So it was very obvious that we had to get involved, leave the animal models and work on with humans and on humans, trying to find a cure and trying to find a vaccine. We soon got involved in the vaccine business. And there was a lot of optimism, as you know, in the mid-80s, that within a few years we would have developed a vaccine. But this is one of the biggest tragedies, that we don't have a vaccine, because only vaccines can solve the problem. Well, I made it clear that for the community, the scientific community, we needed Gallo's publications in 1984 to be convinced. We, of course, saw the Montagnier paper in '83, which gave us a certain hint that a retrovirus may be involved, but it wasn't convincing at that time because there were so many other theories that floated about the origin of HIV and of AIDS. And I think the 4 Gallo papers in 1984, they were convincing. So I think the final judgment, co-discoverer for both of them, is fair enough.
Just to digress for a second, in your last answer you talked about Montagnier's 83 papers, and you said it was suggestive, it wasn't confirmed. What were the holes in his early research that didn't convince the scientific community that HIV was causing?
Well, in that paper, he had only one electron micrograph, and the virus could be identified as sort of a retrovirus, but it could have also been an arenavirus. Now, these are specifics that are only important for experts. But when we saw that photo, we said, suggestive, but not convincing. He didn't have tissue culture. He didn't have an immunological reaction yet. We said it was a good incentive for groups like Gallo, our own, and so on, to look for retroviruses in the Buffy code, in the white blood cells of the people affected. As I said, suggestive evidence, but not convincing, at least not for me.
The pictures, his micrographs, are there other particles that look like HIV but might not actually be the virus?
Yeah, it's always a bit risky. I mean, we have a very good electron microscopy here in this institute, but it's still risky sometimes to base a diagnosis entirely on morphology. And in this paper and in this one photo, it was simply not convincing. Well, Gallo, of course, after the Montagnier paper, knew or learned a little bit on what to focus, namely on white blood cells. He had discovered what we nowadays call interleukin-2. He could keep the white blood cells alive, going for several weeks at least, and he had to feed them with fresh white blood cells. It was very laborious what Mika Popovic did in the laboratory of Bob Gallo, namely to feed the tissue culture all the time with fresh white blood cells to keep the virus going. So Gallo depended on some of the initial observations of the Montagnier lab, but then, as I said, in my mind, provided the convincing evidence that HIV is associated with the development of AIDS.
What was the most convincing thing in Gallo's papers? Like, what cemented it for the scientific community, in your opinion?
Well, he already had preliminary serological data. He had antibodies in the people that apparently were suffering from what we called AIDS then. And therefore he presented this antibody test, which was urgently needed by the blood transfusion systems worldwide. And it was quickly realized that everybody who apparently was ill and from whom virus could be recovered and was quickly recovered by other labs within weeks, had these antibodies. And then, of course, he provided the means or described how tissue culture could be performed. And then it was that easy. Within weeks and months, many labs in the world, including our own, had their own isolates.
Did you guys use Gallows ELISA, or did you use Montanili's?
I personally used Gallows ELISA. I brought the virus to Germany in late May 1984, at a very early stage. Within 4 weeks, we had the ELISA test system established, which had tremendous practical consequences, because we offered it to the blood banks and on a non-commercial scale before the companies were ready to get into the market, like Abbott, for example. And this helped to clean up the blood transfusion system. And nevertheless, about 1,500 of our 4,500 hemophiliacs were infected, which of course was a disaster.
What was that experiment that cemented the causative role between HIV and AIDS?
Oh, there were quite a number of experiments. For one thing, it was then quickly realized, also from our lab actually, that monkeys had retroviruses that were very similar to the human HIV. It was then suggested and later on proven that HIV originated from old world primates. We worked in Frankfurt with African green monkeys. They were full of SIVs, the simian immunodeficiency virus. And then we could take this virus, go to other monkey species like rhesus monkeys, and induce the disease within months. So this was, from the animal experiments, very good evidence that HIV, respectively SIV in monkeys, are the causative agents of this immunodeficiency. And then we had 100%, which is unusual, 100% association between this immunodeficiency and HIVs that could be isolated from these people. Because these people are chronic carriers, the virus is not hiding, the blood is full of high titers of HIV. It was easy to isolate in tissue culture virus from all these people. So this was pretty convincing evidence.
Were you involved at all in the early experiments of isolation, purification, like Gallows group and Montanili's group?
We were at the same time in 1984 trying to isolate something, whatever that could be, from the blood cells of those gay people apparently suffering from immunodeficiency. The others were a few months faster, which is probably due to the fact that at the same time we discovered human endogenous retroviruses and wanted to stick with this discovery.
Can you visually explain the process of isolation and purification? You know, how one goes about searching for something that they've never seen before?
Well, you knew at that time we didn't have PCRs. I don't know, you're familiar with the field, I suppose, yeah. At that time we didn't have really PCRs, we had, which is now a gold standard to look for novel infectious entities. What the few labs did who had experience with retrovirology is start a tissue culture system. You need to have tissue culture, we knew that. Because in vivo, normally these lentiviruses don't even replicate. HIV, we learned later, is a big exception. And what we did, we isolated the white blood cells from from suspects putatively infected by HIV. I had this tissue culture growth factor from Bob Gallo, which is now called interleukin-2. Where one of the early steps is then to take small samples and give it to the electron microscopist, like Hans Gelderblom, with whom I was collaborating, and also in Frankfurt other electron microscopists, but he's one of the most experienced people in the field, and say, have a look, I mean, can you find something? And initially he couldn't, later on he did. And then we stimulated these white blood cells, trying to get them to replicate, to cell division, to divide, because we knew that if it is a retrovirus, it probably usually comes out only after mitosis. And we knew that from animal systems. And then in mid-1984, just at the same time as Robin Weiss and Jay Levy, we had the same electron micrographs, and then we had reverse transcriptase in the supernatant. And well, then it was clear that it was clear that the retrovirus is in those cells. It wasn't definitely not yet clear whether it's a causative agent. What one does is one gets those white blood cells from people who may have a risk for being HIV infected or have already developed clinical symptoms and disease, and then you take cells, white blood cells from a healthy blood donor for comparison. Then you put them into culture. You try to keep the cells alive for days, hopefully 2, 3, 4 weeks. You add all sorts of growth factors that may help the cell to divide. You then take, after 5 to 10 days, you take out samples, give it to the electron microscopist, telling him, have a look at it, do you see any retrovirus particles? Then there's an assay system like the reverse transcriptase assay, which is a very good convincing indicator that retroviruses are in those cultures, and you compare then with the white blood cells from a normal healthy blood donor, and if you come up with a positive result, in other words, reverse transcriptase assay is positive with a deceased person but negative with a blood donor, then you have an exciting indication that a retrovirus may be in the culture of the patient but not in the normal blood donor. That's what we did, that's what others did. It was a race, whoever would be fastest, and Montagnier came up with preliminary data, and I think Gallo confirmed the data. So, and several others like Jay Levy, Robin Weiss, our own lab, followed suit.
And when you've never actually seen the infectious agent before, how do you identify it? Like, how do you know when there's something?
If you have never seen it before, you might well miss it. It then means the reverse transcriptase assay could be learned by every virologist, although it's a tricky assay initially. And then an electron microscopist who's looking at those virus particles may also miss it, because there are other virus families that look very similar. And sometimes when the virus production is so low and the electron microscopist doesn't have enough patience and a trained eye, he may miss it also. But in Germany we had some very good, and still have some very good retrovirologists in electron microscopy. Therefore, we had very good support from that side.
And my last question for that is, what is the purpose of the high-speed centrifuge, the gradient?
Well, once you have then in the supernatant, or you suspect in the supernatant virus particles, they are extremely small. They can only be seen in the electron microscope and not in the light microscope. And for a positive so-called reverse transcriptase assay, which is a characteristic of retrovirus, you have to concentrate the virus. Now, since the virus is so small, you have to go to an ultracentrifuge, rotating at a speed of, let's say, 80,000 rounds per minute. And this is fast enough then to sediment the virus, get what we call a little pellet with billions of virus particles in it. And then you can do both a reverse transcriptase assay on that material, a biochemical assay that is, and you take another aliquot and give it again to the electron microscopist, tell him to have a look at it, what's in there, and hopefully, in that case, a retrovirus is in there. Well, the AIDS virus, HIV, has the typical properties and characteristics of a retrovirus, namely, once the cell is infected, the virus inserts its genetic material into the cell. Subsequently, the genetic material behaves like cellular material, and the most important consequence is that nobody ever, to my knowledge at least, has been cured from a retrovirus infection. No animal and no human being. And that means whoever gets infected will remain infected as long as he lives. And although despite all the major progress we have in chemotherapy of those patients, none of these patients got rid of the virus. It's a big difference.
In terms of the family of retroviruses, what kind of virus is HIV?
Well, if you want a scientific answer, I could say it's a lentivirus, but there are several subgroups, but they are virtually all more or less pathogenic in animals and in man, to various degrees. But HIV, unfortunately, belongs to those two groups of viruses that are 100% lethal if not treated, namely rabies virus and the retrovirus HIV.
Some people are very fortunate that they don't have these side effects. But many do. So